So, greetings, greetings everyone. Pleasure to be here. Yash Joshi this side, and today I will be presenting about my work on initiator attribute that is a proposed addition to the resource timing API. So let's start with the definition of such an attribute. This new proposed attribute will be presenting information about the initiator of a particular resource. Initiator here refers to any resource or entity that basically causes or is responsible for the fetching of a particular resource, of a current resource. I have attached a detailed explainer along with a self privacy and security review in the slide deck itself. So feel free to have a look and chime in your thoughts there as well. Uh, Regarding the need for such an initiator, we have had a lengthy discussion on the resource timing repo itself in issue number 263. So feel free to have a look through that as well. Summarizing the important bits for like so that everyone is on the same page here. The main motivation for building these kind of attributes is to help in because this will help in identification of parent resources that basically triggered the fetch of a particular resource. This will enable us to build accurate dependency trees, and we believe building of accurate dependencies tree can open a bunch of possibilities. For example, run providers can use the detailed insight to get can use this. Can use this accurate dependency tree to get detailed insight into resource loading and third-party script cost. For example, they may trace back the resource to the LCP and find out elements that are on critical path to LCP, or they may find culprit third-party scripts that may be loading a lot more bloatware or other scripts that were not intended. So, like a bunch of interesting optimization that can be done there, but once we have this info in hand. Apart from that, we also think that security products can also potentially benefit from such an attribute where they may be able to better backtrace these rogue requests. So these were about the use cases. Now moving forward to what this attribute will basically do. So this initiator attribute will be pointing to the identifier of the parent resource that basically triggered the fetch of this current resource. So regarding this identifier, we have had a discussion previously in the working group itself where we discussed whether it would be better to have a fetch ID as as an identifier where we are uniquely identifying each fetch request, or will it make more sense for us to like go with a resource ID kind of a thing where we are uniquely identify every resource, and then it was concluded that it would be better to go ahead with the resource ID. So like this resource ID does not need to be exposed as a separate attribute. Basically, we propose it to be a very simple string concatenation of the already present URL and start time attributes of a particular resource through its resource timing entry. A simple string concatenation will basically give us the resource ID, which this initiator can then point to as the parent resource. To understand that, let's just have a brief look over what the API endpoint shape might look like. So like this initiator can be a simple read-only attribute type DOM string addition to the already existing performance resource timing entry. And regarding the usage, it will be very similar to how we utilize the other members such as content type or name. In the front of your screen, you can see I have shown a very basic example where I am just collecting the resource timing entries and then logging the initiator for one of those entries. Very simple. The login will be done in the form of like the resource ID will be in the form of www.example.com/start time. The start time I am taking here as 0. We are yet to discuss like we will be discussing on where this 0 may come from. So yeah. So there can be a bunch of cases where we can like calculate this initiator and resource ID thing. So for the most basic cases, we plan to like point to a single culprit there. For example, in the case of where the HTML document is the initiator. So for these cases where the resource fetch is basically initiated by HTML tags such as link tag, image tag, or an iframe tag, or inline scripts. Even in the case of inline script, we think that it would be best to attribute these kind of resources back to the document itself. Like the document will be the initiator for these kind of this kind of resource fetches. One caveat here, though, like the document does not produce a resource timing entry on its own. So we can query for that. We can query the navigation timing object, and since there is only one hard navigation timing entry per page, we can derive the URL and the start time from there as well. Interesting observation to note here, like in this case, there the start time will always be 0 because in the hard navigation timing, we allot the start time as 0 for the document itself. So what this kind of mechanism will does is bring better code readability. So like any developer who is looking into the initiator attribute and seeing a /0 after example.com can immediately identify that this is initiated by our document itself. In Chromium, regarding the implementation, a brief look at there, we are just utilizing the parser preloading thing to like point out to the resource, whose fetch has been initiated by the parser preloader itself, to identify the cases where this like where the HTML, where this initiator attribute can be tied back to the document itself. So that's how we have been planning to implement it in Chromium. So another case where this can be thought of is the CSS case, where any style sheet is basically requesting resources, such as a style sheet can request for another style sheet using port statement, or a style sheet can request for images using background image thing, or they may request a bunch of fonts. So for these cases also, we think we can point back to the style sheet as the initiator, and that would do. A very simple example can be www.example.com/stylesheet.css slash the start time, that will be 256.256, etc., etc. So these are the most basic cases of where we can very easily point to a single culprit as the initiator for these kind of resource fetches. Uh, Things go a little complex where we have a non-line script as the initiator. So what we can do here is we can utilize the underlying task attribution infrastructure to directly point out to the direct parent script, or parent script that initiated the fetch for this particular resource. But a few things to note here, things can go a little complex here, because there can be a possibilities of multiple scripts that basically influence a single resource that has been loaded, and there may be we identify a subset of cases where having potential list of blockers versus a single initiator might be much more beneficial. So we can just look at the example to understand this. So let's start with the on stack script case. So we can just think of a carousel that relies on some library code to serve up a resource. So in our paradigm, what we will be pointing to the initiator is the carousel for this resource. But if we look at it in a practical manner, for uh, s- uh, like to move the to fasten the resource loading, we may need to optimize both the carousel and the library code that it relies upon. So it is a very simple case of where we think like if we have this potential list of blockers where we are listing both library as well as carousel as the potential blocker or initiators. So that can be much more beneficial for the web developers to have an idea about. Uh, some more ideas here is of some more examples here is second of a preceding deferred script. Consider this example where we have three deferred scripts. The carousel still relies on the library code to like serve up the resource, but here we have a button.js. Like since these scripts will be running in a sequential manner, this button.js will be blocking the execution of carousel even when it's not a part of call stack for this resource loading thing. So like here also the same things apply there. Moving forward, this is a async case. For this async script case, we can see that it's an implicit dependency and a very racy one. So we can understand this if it is not loaded, if this library.js is not loaded, we will ultimately getting a JavaScript error. So these were the basic cases. A bunch of interesting observations to note here is like whenever a script loads a resource, we saw that there could be code from other scripts in the JavaScript stack that does that loading, or there could be other scripts that basically simply block the loading script from executing until they do. For example, that was the case with module script or with deferred script or module dependencies. And they can be both on stack or off stack. So like with this, I open a bunch of questions, ideas that are open for this discussion and some questions. Uh, the overall idea is to get some opinion on how we should represent this complexity in case of non-line script, as in case of where the non-inline script is the initiator for different resources. For example, one option can be to represent it in a single initiator. That was the former implementation, where the script that directly loaded the resource that directly loaded the resource is being pointed in the initiator attribute. And then in the future, as a separate effort, what we can do is add a list of scripts that basically potentially a list of scripts that potentially block script execution and name it different attributes, say blockers or initiators or something else. This will not necessarily cover example 3 of the async case, but there can be another argument from other side that this is fine, that because the situation was racy itself and may likely result in a lot of JavaScript errors. So like it's a very fragile coding pattern to go there. Uh, like the another option is to turn this initiator itself into a list and try to try to present all the potential blockers for a resource inside that list. So we can like understand in our paradigm, what we can do here is to like break this thing into two different parts where we have a loading dependency tree and an execution dependency tree. So what we can do here is like uh, for the loading dependency tree, we can have initiator attribute like which will point to the initiator that directly initiated the resource loading of that particular resource. And then we can have an execution dependency tree where we can have a list of potential blockers that basically stop that. Like if there is a delay in any of the blockers, then the particular resource may be delayed or may not even load at all. So like, what do you all think, like whether it would be worthwhile to like ship a single initiator on its own, and whether it would be worthwhile to like, will this give enough information for the web developers to have some interesting optimizations there, or whether it would make sense to just go with the multiple initiators part. Uh, that was all the ideas that I needed some opinion upon and some interesting ideas there. That all this write-up has been presented in the GitHub issue RT380. So feel free to have a look there. I have explained in detail and will love the comments there. So I am open for questions now, if you guys have any.
Awesome, thank you. Yeah, hi, I'm Kenneth from Intel, and I'm going to present the compute pressure to this working group. So compute pressure actually was originated by Google. They had use cases for, well, you have a system, it's under some kind of pressure. It could be compute pressure, like actually CPU. It could also be thermal, memory, I/O, other kinds of pressure. Initially, the use came up during COVID. A lot of native apps, especially something like Zoom, using right now, Meet, etc., are actually looking at the pressure on the system to provide a better user experience for the users. First of all, maybe if you're playing a video game, it's fine that your computer is hot to the touch and the fans are all spinning. But in a quiet meeting, that would not be so nice. So just like you probably know from streaming media such as Netflix, Disney Plus, they're just like giving bandwidth. You adjust like the streams to low resolution to ensure that it's watchable and not blocking all the time. And you can do something similar on a computer. With streaming, you could like adjust the amount of video streams, say, oh, I can't keep up. Maybe let's just show who's actually talking, lower the resolution. You could turn off certain filters. You could maybe you're doing like backup rolling on the client, maybe move that to the cloud instead, or the other way around. There's definitely a lot of options here. So there's of course a lot of challenges in doing so. First of all, something like a CPU pressure state is global state, so that could be potentially used for some sharing data between apps that are not supposed to share data, for instance, one in incognito and one not in incognito. There's also quite privacy invasive. If multiple applications can get the same state, very detailed, like sensors of utilization, frequency, and the like. So we have to strike the right balance between these high level states and low level data. And then there's all the questions around like, do we need that permissions prompts? Do we need permissions prompt? How's that going to work? Because if you have too many permission prompts, people get fatigue and just like answer at random. So after looking at this many, there were some approaches from Google. I took over from Olivier, and we ended up with a system that has like 4 states, nominal, almost.
Can you share that slide because it's quite small?
Oh, yeah, I don't have to share the slide. Can I share the slide later? Okay, yeah. I don't know if I can zoom. There's that. Oh, nice, yeah. It's a bit slow. So, yeah, you have nominal. So it's basically when there's not a whole lot going on in the system, basically more or less idling, maybe just looking at it like I am right now. Fair, there's some kind of pressure going on, but it's doing great. Serious, okay, now you might be reaching the limits, close to thermal. Critical, you're definitely not doing well. You should stop what you're doing and see if you can do less. This is not, it doesn't always depend on you. There might be other applications running on this system. So it's just an indication. And by talking to, we collaborated as we normally do when something is part of the Project Fugu project. We talk to clients, so Zoom, and ask like, what are your use cases? How do you like the API shape, all of that. And one of the emerging use cases for a lot of these streaming services is kind of like embedded SDK use cases, like you go to a doctor's appointment and it will embed this SDK, it will also like use an iframe, and then you also talk to the doctor, etc. So we also had like requests to support it in workers, so that the whole API is designed in a way is based on the observer pattern. And it supports like dedicated shared workers and users from iframes with the privacy policies, etc. I have a small video of this one where you can kind of see how it works in a simple manner. I have this emoji web component done with compute pressure that will show the pure pressure, and I'm doing this Mandelbrot simulation using web workers. So it's just like adding more web workers. I'm kind of increasing the pressure of the system. Here showing that I can get into critical on my laptop, and also that if you stop doing things, things going to go down again. So just a very simple demo of the feature. But of course, like as I said, global state could result in privacy issues. So talking also to the ping, we talked about this side channel attack. Maybe once it's already done in a way that you can only have it on one side at a time. But if you go to one side, you kind of calibrate the state, you find out, oh, with this particular workload, I will always go into critical, or I will always go into nominal. You could kind of use that for broadcasting data. And then in the future, while you're on a totally different, unrelated website, they might be able to snap up your, if let's say like Facebook is broadcasting your user ID, then maybe you're on Pornhub and they catches that user ID and now they can reach you, maybe collaborating behind your back. Not so nice. So we actually went ahead and I will say that if there's something going on the PC, like some background processes, other apps open, it's highly unreliable. But if you have a very quiet system, I actually make it possible to like share something like hello world. Sometimes you get a bit too many, one too little, it gets unaligned. So I had to add some validation code like checksumming that could kind of like realign the bit stream and then also send like a number, like position. So if you didn't get it all the first time, maybe the next time. So maybe if you lay a computer, let it not doing anything for an hour, maybe you could transfer hello world. So as you can see here, like I calibrated it manually. Let's do this. So I have like, if I have 0 workers on it, I kind of get the 0 value. I have a reset value. So I kind of like can go 0, reset 0, reset 0, if I have multiple zeros from each other. And for the one value, I have 6 workers, then I get into critical on this system. And here we have some of my colleagues trying it out. So the Arno here, he got like 81% transferred first time here. My colleague Wei in China, his system is much better at doing this. So yeah, so of course, like with this, that is of course not ideal. So the way it works is basically I just decided nominal fair, 0-bit. It's pretty hard to rely on being at nominal. Serious will be resetting, critical useful 1, and then I do this alignment trick. So of course we worked with the ping on finding ways that we could mitigate this. There's basically 2 mitigations. We have in the spec. One is for breaking the calibration. So if you do the calibration, it's not really so important exactly what point and what kind of pressure the CPU is under for going from one state to the other, because it's high level. So we could change that one. So if you have calibrated, maybe after 10 minutes, you haven't calibrated any longer because we changed that slightly. The other one is we kind of like try to identify that people are abusing the system is very abnormal compute pressure. And in that case, we we introduce some penalty, and if you could continue doing it, you might get worse penalty. And we have tested this out, and this really makes a huge difference, basically making this a non-stop error. So how's Spec doing? Well, we've gone through a lot of reviews, talked to the Google privacy and security team a couple of times. We've gone through the ping review. We had a stability review today. We're getting some PRs to get merged. Tech review, instrumentation review, and it's currently it's available as an active origin trial in Chrome. So we have some people trying that out. We know of at least Zoom, whereby I talked to Andreas Bolton, who's here today. They are playing around with it. And we also know that Slack is using it and would like it to support thermals, which is one of the, we have that plan. So yeah, lots of interest, going great. We do hear though that, and I don't know if this is just out there, maybe to get some feedback as well. We do hear that some people really like more low-level access, especially for if they have, like, say you Meet, for instance, or Zoom, and you have a new code path and you think this is great, this is going to be better, but I really want to test it on live deployments, because maybe there's a certain system where this is just not going great and they're all going to end up in critical state all the time. So how do I do that? And we've been told that people like access for that. If that is the case, as you see with such attacks, that's not going to be an easy thing to do, unless you invent something very different. So some people have talked about maybe we could be like in the old days in video games, where you kind of have like an optimized step, and then you have like 5 minutes. It's going to run something. I could see that as a debugging thing. Maybe if you go into Zoom settings and it's debug thing, would that be acceptable? Maybe with the basic UI, really sure that the users know that something abnormal is going on, like I'm measuring your system. So like we're thinking a bit about that, and we'd definitely like to hear some feedback. So yeah, that's basically it. Any questions, comments?
Question.